Determine the limit as x approaches positive infinity of f of x if f of x sits between x squared minus 2x plus 1 divided by x squared plus 4 and 1 minus 2x plus 1 over x squared. F of x here sits between x squared minus 2x plus 1 divided by x squared plus 4 and 1 minus 2 divided by x plus 1 over x squared. We can take the limit as x approaches infinity of each of these, and the inequality will still hold true. So the limit as x approaches positive infinity of x squared minus 2x plus 1 divided by x squared plus 4 will be less than or equal to the limit as x approaches positive infinity of f of x, the limit we want to determine, which will be less than or equal to the limit as x approaches positive infinity of 1 minus 2x plus 1 over x squared. Starting with the leftmost limit, the first thing to do is plug a positive infinity in for each of the x's. Only the highest power term in the numerator and denominator will matter here. Positive infinity squared is positive infinity, divided by positive infinity squared is positive infinity. We have the infinity over infinity indeterminate form here. We will need to rework this, and it will be reworked by dividing both the numerator and denominator by the highest power of x in the denominator. So we'll divide everything by x squared. So we'll divide each term in the numerator by x squared, and each term in the denominator also by x squared. The middle limit is the one we want to determine, so we will leave it as is. The rightmost limit, the first thing to do is plug a positive infinity in for each of the x's. Each term that is a constant divided by x to a positive power will go to 0 as x approaches positive infinity. The result is 1 minus 0 plus 0. Back to the leftmost limit. In the numerator, the first term, the x squareds, can fully cancel, leaving behind a positive 1. And the second term, one of the x's in the denominator, will cancel with the x in the numerator, leaving a minus 2 over x. The third term has no x's that can cancel. It will remain as a positive 1 over x squared. In the denominator, the first term, the x squareds, will fully cancel, leaving a positive 1. The second term has no x's that will cancel. It will remain as a 4 over x squared. The middle limit we will leave as is. And the rightmost limit is 1 minus 0, which is 1 plus 0. Back to the leftmost limit. Each term that is a constant divided by x to a positive power will go to 0 as x approaches positive infinity. The result is 1 divided by 1, which is a 1. Leaving the middle limit alone. And then 1 plus 0 is a 1. So the middle limit is being squeezed between 1 and 1, and therefore the middle limit as x approaches positive infinity of f of x will equal 1 due to the squeeze theorem. And we have determined the limit is given.